Hello again. Here we are with another math class, and we're getting closer and closer to the next test. I would say it's coming up very soon, and I'll let you definitely know when that's going to be, and we'll definitely review before you take it. Probably the class I do that within, I will probably do a review with you first, and then give you some time that particular class day to do your quiz. All right. So we're almost mid. If you're in summer school, you're mid-course here with this class. So here we go, and I'm going to start by reviewing the homework last night, which was 11B. So give me a second to share the screen here. We'll bring up the sheet 11B, and you'll be able to see, okay, the questions, and hopefully you've got your sheet 11B handy. And we'll go over that. And we're going to find out there's some more stuff we have to add in today to what we're going to do. But you're also going to find out that I've been crossing out a lot of stuff on these sheets that I'm not worried about you knowing for the second test. So don't be annoyed by that. Just be aware that that is happening. And I just want to let you know that that's why I'm doing it. And so with no further ado, let's get going. All right, the very first thing I asked you to do was once again write the definition of a rational number. And I'll just write her down again. Any number that can be expressed as the quotient, you also could say division, of 2, and you got to remember it's integers because they can be negative numbers, the rationals, okay, in the form A over B, B cannot be equal to 0. That could be P over Q, Q not equal to 0, as that was done in the other videos that you saw in the previous class. So guess what? I wrote that up above where the definition was supposed to go, but that's what's supposed to go in there, right? Okay. Describe the decimal behavior of a rational number. All you really need to write down for me is this: R or T. If you want to say baby afterwards, I don't care. R or T. What's R mean? They either repeat as decimals or they terminate, stop, okay? All right, remember Arnold Schwarzenegger and the Terminator. That'll help you remember terminate. So repeating decimals, the decimal behavior of rational numbers is they either repeat or they terminate. Describe the decimal behavior of an irrational number. They don't repeat, don't terminate. You'll also add to that, they go on forever and can show a pattern. What do I mean by that? Let me refresh your memory on that. This is an irrational number that goes on forever showing a pattern. All right, negative 23.62, 622, 632s, 642s, ... The pattern continues to grow in size as the number goes on to infinity. The 3 dots are saying to us, continues in the same pattern. So you know it's going to continue to grow in exactly the same way. Okay? So when I say it can show a pattern, all right, it doesn't have to. An irrational number can goes on forever But the numbers can be all over the place, okay, with no kind of pattern in them at all. But they do not stop. They go on forever. Remember, square root of 2, pi, the golden ratio phi. Those are all examples of irrational numbers, okay? So keep that in mind. All right, let's take a couple seconds and practice finding out whether or not these statements are true or false, okay? Is 57 plus 8 times 3 the same thing as 2 mod 10? Well, 57 mod 10, you know, is just 7. 8 times 3 is 24, right? 24 converted to a mod 10 number is just 4. So I get 11 here. And 11 is just what? 1 mod 10. Well, that's not equal to what? That's not equal or equivalent to 2 mod 10. So the answer to this is it would be false. That's a very easy question, right? Particularly because it's in mod 10. All right, if we go to the next question, B, which of course is mod 16, a little harder, right? I suggest if you're a little uncomfortable with these, just work out the left side, get the normal numerical answer, and then take your answer and convert it to mod 16. So let's practice that. 5 times 12, I believe, is 60. 9 times 13 is, I believe, 117. Okay, I'll double check that just to be sure on my calculator. All right, 9 times 13 is 117. Excuse me. I add it to 60. And when I do, I get 177. Now, is that equivalent to 14 mod 16? To find out, I must divide by the mod number. So I divide by 16. When I divide 16, excuse me, into 177 on my calculator, 177 divided by 16, I obtain 13.615. It keeps on going. So as a whole number, it's 13 point, and it goes on, all right? So all I do is multiply 13 times 16, 13 times 16, so I can get the remainder here, all right? Now, wait a minute, something isn't making sense here, all right? Let me try this again. I'm going to take 177, and I'm going to divide it by 16. When I do, oh, I gave you the wrong answer here. This is 1106 something, all right? Got to keep an eye on me. This keeps on going, all right? So I have to do, excuse me, 11 times 16. So 11 times 16 gives me 176. I'll put it here. So that's the same thing as what? That's the same thing as 1. Is 1 equivalent to 14 mod 16? No way, right? Therefore, this is also a false statement. So when you do these on the test that's coming up soon, you've got to make sure that you do the conversion of the stuff on the left like a normal problem. Just work it out and then, excuse me, then convert it to the mod it asks you for, and you should be able to do that and get your answer. All right, explain carefully why we're guaranteed that a room filled with 40 people, that's PHP, baby, and that's not on the next test, so I'm skipping it. And I'm not putting any folding questions on the next test. And I'm also not putting any prime factorization material on this next upcoming test. So I'm going to leave those out and not have you worry about them. That's why I crossed them off for when you did your homework. Okay, let's take a look at the bottom here. State whether each of the following that follows is a natural, whole, rational, or irrational number. Well, 237 can be what? It can be natural, You can count to 237. It can be whole, and it definitely can be rational. It can be placed over 1, which means it would be a fraction, so it would equal 237. So all those answers are correct. That also could be an integer. I didn't ask you to include it as an integer when I set up this problem, but it is also an integer. How about 3 and 5/9? Obviously, it's a fraction, right? 5/9. So it's a mixed fraction, but it doesn't make a difference if it's got a whole number part or not. Okay, 3 and 5/9 is definitely a rational number. Just remember, fractions, which are made up of a quotient of 2 integers, are all rational numbers. Radical 2 or square root of 2? No. Square root of 2 is an irrational number. If you work it out on a calculator, you'll see it comes out 1.414. It keeps on going, but it doesn't show any kind of pattern, and it doesn't repeat, and it never stops. So it's irrational. Phi, the golden ratio, irrational. 1.618034 is the approximation we use for phi, but it is not the exact value. The exact value has a radical sign in it, right? 1 plus the square root of 5 all over 2, which tells you that number is definitely irrational. 9.3 bar, well, 3 is a repeating decimal, right? Repeating decimals are or can be written as fractions. Therefore, that is a rational number. Now, we really can't tell about the next number, right? This was rational. This was irrational. This is irrational. Let me put this down. This was rational, and you know what that was. Okay, now, this number appears to be irrational, as best we can tell. It appears it goes on forever, and the numbers are all over the place. So I would allow you to assume that this is definitely an irrational number. Okay, let's go to the back of the sheet, or your second page. Determine the missing number in this bank routing number. You had to do a UPC code, and you had to do 2 other ones. I tell you what I'm going to do. I think probably you're pretty good at these right now. So let me just switch over to the answer sheet here. All right. There are the answers to 9 and 10. You should have gotten that the digit X up in the bank routing number should have been a 7. And in problem 10, you should have gotten the fact that the third digit in the UPC code is an 8. Okay, now notice I do have the credit card worked out here. Why am I not discussing credit cards with you? They work on a little different system. And what I would like to suggest that you do is go online sometime and ask, how do they check credit cards? And you'll find out there's a rather unique coding system that you multiply by any credit card. And it does also have to come out 0 mod 10, but it has a couple wrinkles in it. Okay, and I've decided not to teach that this course during this course because it's a little bit confusing, and I don't want to mess you up on your bank routing numbers or your UPC code. So I'm skipping credit cards. All right. Now here are the other 2 questions you were trying to do on the homework. All right. I guess I put 11 and 12 down twice supposedly here. I guess I don't know how to count. But at any rate, there they are, and the answer was 8. And then the second to the last question, the answer was 7. Now, if we had been meeting in a normal class setting, I would have checked your homework right away as you came in the classroom. And while I was doing that, I would have given you a sheet to try, and then we go over it immediately. Well, I haven't given you the sheet to try, right? But what I'm going to do is I'm going to go back to this sheet, all right? Or go up to this sheet. Probably the easiest way to do it is this way. Going up here. Oh, that's not right. Where the heck is it? Oh, it's at slide 62. Sorry. So I'm going back to slide 62. I read the wrong slide number. And what we're going to do is we're going to take a look at these questions together quickly. All right. Which computation shown of A, B, C, and D is not correct? Well, 10 to the third, worked out on the left, is 1,000, right? What is 1,000 in mod 8? If I take 1,000 divided by 8, okay, on my calculator, 1,000 divided by 8, I obtain exactly 125. What does that tell me? 125 times 8 is 1,000. So, is it 0 mod 8? Yes, it is. So A is okay. I'll put a check mark next to that. All right, let's go to the second one. What is this number mod 10? Well, you know 8 times 12 in B there is 96, which is just 6. 30 is 0. 6 plus 0 is 6. So it appears that B is our correct answer. Now, just in case your teacher here screwed up, let's check out C and D. In C, what's 4 times 12? It's 48. I want to change 48 to a mod 5 number. All right, if I take 48 and I divide it by 5, I obtain 9.6. So I use a 9, I throw the decimal away, 45, the answer is 3. That answer appears to be correct. Okay, on a mod 10 clock, the time 12 hours past 3 is 0. Mod 10 clock, that is now, right? If I go 12 hours past 3 o'clock, that would be 15 o'clock, right? And 15 is what? 5 mod 10, not 0 mod 10. So C and D also check out. All right, well, wait a minute. It says which computation is not correct. Okay, on a mod 10 clock, the time 12 hours past 3 is 0. This is also not correct, right? So it turns out there are actually 2 answers there which were not correct in that group of answers. Okay, so A and B were fine. Okay, let's go on. To the right are listed 3 consecutive Luca numbers. What is the next number in that series? Well, if you recall, all I have to do is add these 2 together. And adding those in my head, it looks like 3571. So it appears the answer would have to be A. Let's go on. Single sheet of paper is folded 12 times. How many individually stacked sheets of paper should have the same or equal height? So what do I have to do to get that? You're going to have to remember this for the final, not for the test coming up, but it would be what? 2 to the 12th power. And what is 2 to the 12th power? If you didn't do this last night, do it now. Do 2 caret 12, and when you do, you get 4,096, which appears to be choice D. Which number that follows in number 4 is an integer? Can't be A, it's got a fraction in it. Can't be B, because it's got a decimal in it. Integers are either positive or whole numbers which have negative signs in front of them. It's got to be C, right? And it can't be D because D contains a decimal. Okay, so the answer is choice C. Okay, number 5. Which number that follows is a rational number? Well, you know phi isn't rational, right? Phi is irrational. All right? Look at B. Now, you have to look at these very carefully sometimes. If you look at B, you see 7575757575 continues to what? It's repeating. It's not showing a pattern, it's showing repetition to infinity. So therefore, it's what? A rational number. How about A? 3, 5, 3, 5, 5, 3, then 3 5s, 3, then 4 5s, 3, then 5 5s, dot, dot, dot. That has a growing pattern in it, right? It's a decimal going on forever. It is definitely what? Irrational. So A was not a correct choice either. The correct choice was B. Got to be careful on questions like this because I often will not use bar notation, okay? If I use bar notation on a decimal, you know right away it's rational, right? So you got to look at the answer very carefully to make sure I'm not trying to trick you. Let's go on. Which number that follows is irrational? Well, if you look at A, 2, 6, 2, 6, 2, 6, 2, 6, that smells like repetition to me. All right? So it looks like A is a rational number. Look at C. Doesn't it terminate? If it terminates and it's a decimal, it's also a rational number. So the answer's got to be B. And if you look at B, you can see 0, 3, 5, 0, 3, 5, 5, 0, 3, 3 5s, 0, 3, 4 5, 0, 3, 5 5s, followed by the dot, dot, dot. You know that's an irrational number. What type or types of numbers is negative 83? Well, it isn't a whole number, right? It isn't a counting number. It's definitely an integer, right? Now, integers can be other kinds of numbers, can't they? Integers can be rational, right? You can express this as negative 83 over 1, right? So it's definitely a rational number. And are rational numbers real numbers? Yes, they are. So the best choice for this answer is this. Pretty close to the best choice here is A, which means it's rational, but it's not the best choice. The best choice, it can be all three types, right? Which number types identify the number below? Well, if you look at the decimal, it goes forever. It does look like it's showing a growing pattern, right? 2, 6, 2, 6, 6, 2 followed by 3 6s, 2 followed by 4 6s. Therefore, you know, right, that that is what? An irrational number. Can it be rational and irrational, as A says? No. Numbers can't both be rational and irrational. Could it be rational and real? Well, rational numbers are all real, but this is not a rational number, so that's no good. How about irrational and real? Yes, this number that you see in problem 8 is definitely irrational, and all irrational numbers are real numbers. Therefore, that is your correct answer. All right? How about D? They can't be rational and irrational at the same time, so it cannot be D. Okay, 9. Which of these numbers is rational? Well, if you look at the first one, it's a decimal that goes on forever. Is it showing a growing pattern? Yes, it is. 8, 3, 8 followed by 2 3s, 8 followed by 3 3s. So that can't be rational. A's no good. How about B? It's a terminating decimal, isn't it? It's negative. That's okay if it's negative. Looks like B's our animal that we want. Look at C. Phi, or 1.618033, with the arrow after it. What does my arrow mean? That the Kellyism arrow? It means if it's after a decimal, that decimal goes on forever and it's all over the place, right? So that's definitely an irrational number. Pi, 3.1415927, does continue all over the place as well. And it has an arrow after it, so you know it's irrational. And E obviously has to be irrational because it has an arrow after it. Okay, what is the exact value of the golden ratio? It is phi equals 1 plus the square root of 5 all over 2. You noticed that was on the first test, right? I told you it was going to be there. State the golden ratio as a decimal rounded to 6 decimal places. You could work this thing out on your calculator, but it comes out 1.6180339. So rounding it, it's 0.34. If you left it 3.3, I'd probably count it right, but it's not really correct. It should be 3.4. Okay, so we took a look at that particular material. Now we're going to go on and start something, well, it's not new, but it's going to be a little new in that we are going to be dealing with some new material today as well as old. But I want to practice all this stuff because you've got to know all this stuff coming up very soon on the next test. Okay. Find the requested information. All right, it says determine a rational number which is between the following two numbers. Okay, now if you recall, the best way to do this is to add the two numbers together and divide them by 2. Their average should be between them, right? Now, I'm going to tell you right now, what you are going to get for this answer would be this. It would be 48.320015. If I stick a 0 on the end of each of these, you can see 10, 15, 20, right? You know the number I wrote down is between them. Question. Am I finished with this question? Yes, I am. I found a rational number between them. Now let me stop a second and just say this. You should have gotten out your sheet 13B, group work 13B, because that's the sheet we're working on now, working on together. You can shoot me a picture of it later tonight to show me that you have actually done it with me so I can give you the points you deserve for it, the 10 points. So please get it out. If you don't have it out already, stop the video, grab the sheet, all right, and bring it back to you where you are, and away we go with the next question, okay? Determine an irrational number which is between the following two numbers. Okay, well, let's see. If you add these two together, and by the way, on a test, I will not give you a number quite this complicated, but you're using a calculator, so it shouldn't be a big headache. By the way, if I put that down as 341 there, I'm sorry, not 341. Yeah, if I put that down as 341 instead of 345 on the end, would it be between them? Yeah, I'd allow that. If you don't really want to add the numbers together and divide by 2, you can cheat and just do it in your head and make sure that you come up with a number that is between them. All right, now question. Is this number irrational? No, it's not. It's a terminating decimal right now, so it is rational. I must make it irrational. All right, there are 3 different ways I can do that. I could simply add a whole bunch of numbers on the end of this that are all over the place and put 3 dots. Since those numbers appear to be all over the place, I would assume that you have picked an irrational number, and I would count that definitely correct. Okay? All right. Let me erase that choice. Whoop. Wasn't supposed to do that. Hold on. Sometimes this board gives me trouble. I don't know why. And it likes to give me trouble. Boy. There we go. I can get back to it, hopefully. Okay, whoop, went too far. All right, now, if I do my eraser down here, and I get everything beyond the 5 out of there. Oh my gosh, come on here. All right. It's doing some very strange stuff. All right, so every once in a while I have to cheat and come up with a way to make it work correctly. All right, now, or to get it back working correctly. Now, what's another way I could do this? You could even not add any decimals to this if you didn't want to, and just put a Kelly cheater arrow there. What's that arrow tell me? You know that this number goes on forever and it's all over the place. So I would accept that as a correct answer from you on a test. Okay? Now, for some reason, it is just giving me trouble. See if I can get to go back. Okay, now, how about putting a pattern on it? You've got a 3, 4, 5 right there. Why don't we do 3? You have a lot of choices, by the way, to do this with. You can pick totally different numbers. I don't mind either way. So 3, 4, 5, 5, 5, 3, 4, 5, 5, 5, 5. You could actually make 2 numbers continuously grow if you wanted to. Just make sure you put the 3 dots on the end, because the 3 dots on the end say it continues in the same pattern. So we have definitely finished this problem. Hopefully you have a good understanding of that now, and when you encounter it on the test soon, you will be fine with it. Okay, this next group of questions, you are to circle each number which is an example of the kind stated at the beginning of each row. All right, I want you to circle every number up here that's an integer. You go ahead and do that right now. Okay, hopefully you circled the following numbers. That's an integer, that's an integer, this is an integer, and this is an integer. The other 3 are not because they have decimals in them and they are rational numbers. Okay, look at the second choice where it says rational number. Is that first one 56.05, 005, 0005, showing that growing pattern? Is that a rational number? No, it ain't. So it's irrational. So here's a rational number. It's definitely a fraction. Here's a decimal that terminates. That's rational. And here is a repeating decimal. So that is definitely rational. Okay, let's pick out the irrational numbers that occur in the category that says irrational numbers starting it out. Well, that first one definitely is showing a pattern, isn't it? So that's irrational. 15/39, nah, it's a fraction. It's rational. 72.5, terminating decimal. It's rational. 58.62 with a bar over the 62. 62, 62, 62, 62 forever is a repeating decimal. No good. Now we can't be sure on the next one, right? But I don't see any pattern in that number. It does appear to go on forever. It appears to be all over the place. So this is an irrational number, more likely than not, too. A real number. All those answers in this one are real. Every single one, right? Because they're either rational or irrational, each of them. So they're all real numbers. Okay, natural number in the next one. Why can't I circle 0? We didn't learn to count with 0, did we? We didn't learn to count with negatives. So this is a natural number. This one is 1036, 72, and 53. Those are all examples of natural numbers or counting numbers. Whole numbers. Well, you can't use -18 because whole numbers aren't negative. -48 can't be used. The rest are all whole numbers except this bugger on the end, which has a decimal on it, which makes it irrational. So, hey, I'm circling the wrong things, right? I'm actually, let me circle them in red. All right, so the whole numbers are 25, 38, 21, 36. I was circling the things that were wrong in blue, right? So let me go back to that. So these are wrong. The ones in red are correct, right? Sorry about that. Didn't mean to confuse you. Finally, what type of numbers are all the numbers listed above? All of those numbers are real numbers, okay? All of them. Some are irrational, some are rational, but they are all definitely real numbers. All right, let's go on to question 4. All right, this is a little different. If asked to produce a number with only 3's and 8's in it, give such an example of each kind of number stated below. All right, how would we get an irrational one? It only can have 3's and 8's. So if I use 0.38, 388, 3 followed by 3/8, 3 followed by 4/8, ... looks like I've got a winner, right? Okay, so that number is definitely irrational. An integer? How about negative 83? Negative 38? 38. But you have to use just 3's and 8's. I could use 838. You know what I'm talking about. All right, rational number, 2 types. All right, I want one that repeats, and I want one that terminates. Well, 3/8, if you divide it out, it terminates. I believe it's 0.375, so we're good. How about 8/3? 8/3 turns out to be what? 2 2/3. We don't have 8 and 3 in this, but the 2 2/3 would give us all what? All 6's. But I wanted you to write it with just 8's and 3's, so I don't want any of this. 8/3 would work fine. Okay? Whole number? 38. Natural number? 38. Real number, you could use almost anything as long as it's got A's and 3's in it. Okay? And has a decimal or doesn't have a decimal. Okay? So, there we go on that. All right, let's go to the back. All right, on the back, you notice I've crossed out a couple of the problems, the credit card problems. Let's race through these real quick to make sure you've got them down. For the bank routing number, it's 739, 739, 739. Okay, 0, 6, 18 or 8, 0, 0, 0, 7x, 24, and 81. This is a 1. This is a 4. What's my sentence going to read? 7x. I got to add the numbers going across. 14 and 4 is 18 and 1 is 19. So it appears it's 19. Let me add the other way just to make sure I didn't mess up. Well, that 0 should be by itself in front. Sorry. All right, 1 and 4 is 5, and 8 are 13, and 6 is 19. Okay, what number must 7x end in so that when I add it to 19, it comes up with a 0 on the end? Well, you can see it would have to be a 21, 7 times 3, right? Because 7 times 3, 7x, I'm sorry here, it should be 7 times 3 would give us 21, and it added to 19 gives us 40, right? So x has to be what? X has to be 3. Remember, the x has to be a single digit number, okay? When you multiply it by 7, it has to end with a 1 to kill off the 9 and the 19. UPC code real quick, 313, 3, 1, 3, 1, 3, 1, 1, 3, 1. All right. 0, 7, 3x. I'm going to circle that. 8, 27, which is 7, 0, 3, 8, 24, which is 4, 6, 0, 6. All right, so let's add across. Okay. All right, 7 and 8 is 15, going from the left, and 7 is 22, and 11 is 33, and 4 is 35. 41, I believe it's 47. I'm going to add back the other way to make sure that I have it correct. 6 and 6 is 12. 12 and another 12 is 24. 27, 30, 38, and 7. Now I got 45 this time. Let's see. Let's add those again. 6 and 6 is 12. 8 and 4 is 12. So that's 24. 27, 34. 34 and 8 is 34. And 8 is 42. Now I'm getting 49. Oh my gosh. All right. 7 and 8 is 15. 22. 22 and 11 is 33. 35. 41. 47 again. Oh my gosh. 6 and 6 is 12. 16. 24. 27. 31. 39. And 7 is 46. Oh my gosh. 6 and 6 is 12. 16. And 8 is 24, and 3 is 27, 31, 39. I get 46. Why can't I get this to work? 7 and 8 is 15, and 7 is 22, 25, 33, 37. Oh my God. I don't know why I'm not getting this. Well, I'm going to assume it's 47. Okay? I'm going to assume it's 47. And I'm going to assume that the number has to, well, you know what? I can cheat and check here, right? Let me look at the back of this. Let's see. Wait a minute. Come here. All right, let's see. It's 49. So maybe I multiplied something wrong. So we know, according to this, it should be 49. So let's go back. And let me change this to 49. 6, 6, 0, 3, 8, 0, 8, 3x, 7, and 0. I don't know. Guess I can't add today. All right. What's x got to be? X has got to be 7, right? Because 7 times 3 would give us 21, which would give us the number we need for this to work out. Now, what I'd like you to do right now is take a couple seconds and do these two problems. I'm going to wait right on the air here on the video and give you a couple seconds to do both of these problems. So I'll shut up now and I'll give you about 3-4 minutes to try them. Now, in case you're having trouble, I'm going to show you the answers to them. Maybe. We'll see. I got 36 in number 10. In number 11, when I added across, I got 46. Both answers turned out that they had to have 8s so that I would get 24s in each question so that they would end up with the zeros. Okay. Now, I'm going to stop this video right now, and I'm going to ask you to watch another video before I go on to my next material that I want to teach you. And I'm going to let one of the rather weird, different video producers show you how we change repeating decimals. You've done it before in your life, but they have kind of a unique way of showing it. And how you change repeating decimals or any decimal back into the fraction it came from. Then I'm going to teach you something that I call the Kelly's Cheater method. Okay, so at this point, we're going to close down this video. Okay, and you're going to watch this next video. And after you have watched that, I will return to discuss some of the results that were shown on that video presentation. Okay. So with no further ado, I will see you shortly.